I'm ready. Let's go ahead and we're going to graph quadratics today. What kind of quadratics are we about to graph? Well, we're going to do it when we have it in standard form, okay? Not in vertex form yet. That's going to come soon. So the idea is when we graph a quadratic, we make something called a parabola. Blue! So the idea is it either makes kind of a U shape, okay, or almost like an upside down U shape as well, okay? And it's the process of like the way things move in kind of like vertical motion, like if you project it, like projectiles, like boo! So the idea is it kind of comes up and it comes back down, or it kind of comes down and then U's back up. So that's kind of the idea. We're going to be graphing these when we have equations kind of like this. But the first thing we're going to start with is we have the f of x or y is equal to ax squared plus bx plus c. Now, each of these letters have very significant components, okay? The first one, a, my leading coefficient, is going to tell me if my graph is going to point upward or if it's going to point downward, okay? I like to tell students that if the a is positive, it's positive, and so we get like a smiley face. But if the a is negative, then we get a frowny face, okay? So it kind of like if our leading coefficient is positive, okay, we're going to get the smiley face. If it's negative, we get the frowny face, okay? So here we go. I now have the second part, or I'm going to skip to this part, which is the c. The c is very much like slope-intercept form, where this is my y-intercept. In other words, this number is going to tell me where it hits the y-axis, okay? Where my graph is going to hit the y-axis, and this is my x-axis. But this guy is going to tell me, like, for example, this would hit the y-axis at -5, so blau, and this one would hit the y-axis at +3. So that's kind of going to be the idea of what's happening there. So I'm ready to graph. Are you ready to graph? Oh, I forgot one thing, and that is the middle here. Now, the middle, that's super important. And what that tells us is it tells me where my axis of symmetry is. Because one of the beautiful things about this is when you have a parabola, you have a part that has a symmetrical aspect. These guys should be matching each other. So this is my axis of symmetry, all right? Now the idea with my axis of symmetry, or AOS, which is how I'm going to refer to it, is that everything's going to be mapping perfectly on either side of that axis of symmetry. So if you figure out what your axis of symmetry is, you can hack half your graph. It's really nice. So I've had some coffee. Feels good. Now, the idea is that I want to go ahead and figure out what is my axis of symmetry on this bad boy. Well, we have a certain equation to find the axis of symmetry. And that equation is x is equal to -b over 2a. If you're familiar with the quadratic formula, you'll be familiar with these components. If you're not familiar with the quadratic formula, I have a beautiful song or a story that I can tell you later. Not right now. Now, the idea is that I'm going to plug in the information that for her, and I'm going to plug it into her. So, with that idea, let's go. Now, the first thing I have to do is I have to plug in -b. Well, what's my b? Well, it be right here. So I'm going to go ahead and I'm going to plug this in right here. So I have a -4, and now I need 2a. So 2 times whatever the a value is, a. A I find right here, and what do I have? Now some people say nothing, and that's really, that's sad because it's not nothing. There is something here. There is 1. There's 1x squared here, so I'm going to be plugging in a 1. So I have 2 times 1, and you're like, why'd you just waste your time? Because I just do it. I plug it in. So now the idea is now I have -4 divided by 2, and what's -4 divided by 2? It's -2. So that means my axis of symmetry is -2. What do I do with that information? I'll bring it over here. You always want to put your AOS right here in the middle of your table, okay? And so we make a table here, and for my x value we said was -4 divided by 2 is -2. So I'm going to plug that in here, all right? Now, this is what I want you to do. When you're graphing quadratics, when you're making parabolas, I always want you to do this. I want you to, step 1, solve for your write down original problem. Step 2, solve for your AOS. After you solve for your AOS, come up with some points on either side of your AOS, because remember, it's a symmetrical aspect. So what's going to happen is at -2, so over here at 1, 2, I have my mirror line, okay? And then I'm trying to find things that are equidistant from my axis of symmetry, my mirror line. Now, hopefully this will make more sense once I actually graph it out. So what are some numbers that are equidistant from -2? Well, I see I have -1 and I have -3. They're both 1 away from my axis of symmetry. So I'm at -1 and -3. And then what's also equidistant? This guy over here at 0 and this guy over here at -4. So I have 0 and -4. So I'm going to plug all these in. and I hope to get a beautiful graph, which I hope to share with all of you. It'll be very nice. So here we go. I need to plug in these numbers now. So I'm going to start with -2. So I actually have to take -2 and I have to plug it in for the values of x. And so please don't forget that when you're doing -2, when we're doing -2, I don't know how well you can see that, so me apologies. Once I'm plugging in -2 squared, remember you're doing -2 times -2. And -2 times -2 is a positive 4. So now we have 4, and then we have 4 times -2, which is -8. Oh my gosh, minus 5. And so now I have 4 minus 8 minus 5. Okay, which is basically like a -13 here. 4 minus -13 is going to give me a -9. That's pretty deep down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it was on the axis of symmetry. So I'm at -2, -9. Blow! Okay, now the next thing that I have, I can go ahead and keep plugging these guys into this equation. All right, so I'm plugging -1 in here now. And so -1, I'm going to put in, blow, blow. And so I have -1 squared. -1 times -1 is positive 1. And then we have 4 times -1, which is a -4 minus 5, which is going to be -9. It's going to be -8. All right? Now, here's the thing about axis of symmetry. If I have found an axis of symmetry, all right, and this is -1, sorry, and if I plugged in -1, I got -8. Then when I plug in -3, I should also get -8. So I'm just going to check that real quick to make sure that I've done this correctly. All right, so I'm plugging in -3 here. -3 squared is positive 9. And then I have -12 minus 5. So 9 minus 12 is -3, minus 5 is -8. Oh, my beans, it worked out. So I have an axis of symmetry. I'm doing this right so far. I feel good about myself. You should too. So now I'm going to plug in my favorite number of all to plug in, which is 0. So if I'm plugging in 0, I say, hey, what's 0 squared? It's still 0. Plus, hey, what's 4 times 0? 0. And then I got -5. So I'm going to plug in this -5. Blow, blow. And then I'm going to go ahead and I'm going to mark this point. So I have -2, -9 marked right here. Yes, I do. And then I have -1 and -8. So -1, -8. Blow. And then I have -3, -8. -3, -8. Blow. And then I'm at 0, -5. 1, 2, 3, 4, 5. And then I'm at -4, -5. So -4, -5, okay? And so I get this shape right here. Oh, it's like a happy face, all right? And then it'll continue up, extending on into infinity, all right? But let's talk about some pieces of information that are important. So what's my axis of symmetry? My axis of symmetry, which is this red dotted line, okay? This red dotted line, that was x is equal to -2. That was my axis of symmetry. What's my vertex? Well, a vertex is like, where does it like scoop? Where is my either my topmost point or bottommost point? So if I have a positive parabola, I have a bottommost point because my smile is infinite. There's no limit to how high it can go, but it does have a minimum. All right? And so my minimum in this case is my vertex. And my vertex will be found at -2, -9. All right? So my vertex is always related to my axis of symmetry. So once you get your AOS, you have half your vertex. Beautiful. All right. With that piece of information, let's go ahead and let's graph another one, all right? And once again, we see we had a positive x here, so we ended up with a positive graph. So now we're going to go ahead and try another one. And with this next one, we are graphing negative x squared plus 2x plus 3. And I see that I have a -a. Ooh, that's probably going to affect it. Just probs. Who knows? But let's go. Let's go. So I'm going to erase this original one because I can do things like that because I'm the boss. All right? Great. So I see that I have an a of -1. So that tells me that I'm going to get a frowny face on this one. I'm sorry. All right? And then I also see that I have a c of 3, which means that on my y-axis, it's going to hit over here sometime at +3. And that's foreshadowing. And then I need to go ahead and I need to calculate my -b/2a. And so here we go. My b in this case is 2, so I'm going to plug this in. So my b was 2, and the axis of symmetry equation is -b/2a, -b/2a. So I'm plugging in a 2 into -b/2a, because my b is 2. Next I'm going to plug in my a, which is -1 this time. What? All right, which will give me -2 over -2, which will give me positive 1. Hopefully that's okay. When you have the same number on top of itself, like the negatives will cancel, which gives you 2 over 2, and 2 divided by 2 is 1. So my axis of symmetry in this case is 1, son. And so here we go, all right? And my axis of symmetry, my AOS, always goes in the center space out of my 5 points that I'll be collecting. So that was my axis of symmetry is at 1, which I will find here. It's going to be a so actually I want to make those dotted lines and not just the noise. How did I miss the 1? How did I, you know what? I'm just going to adjust the graph because I get to do that. All right. Now, let's continue. Once I plug that in, I need to figure out, hey, what are the points equidistant from this axis of symmetry? Well, I've got 0. I've got positive. I've got 1 away over here, which is 2. So that's 1 away, 1 away. Hope that makes sense. And then I'm like, hey, what's another away? I have negative 1, and then this is going to be 3. Always find your axis of symmetry first, and then figure out your other points. Okay? Okay? Okay. So now we go ahead and we plug in 1 into this equation. I'm looking at negative of 1 squared plus 2 times 1 plus 3. So remember, the negative's on the outside. I have this bad boy squared. Hey, what's 1 squared? It's 1. And then I have a negative. So I'm negative 1 plus, hey, what's 2 times 1? Oh, it's 2 plus 3. That's going to give me 5 plus negative. Actually, I should go PEMDAS, and I should go from left to right. My apologies. And we have positive 1 plus 3 is 4. So over here I have 4. Now I've got a vertex, which is 1 and down 1 and positive 4. Almost made that mistake. All right, cool. So now I have a vertex. All right, and now I'm going to plug in 0 into this piece. So I plug in 0. All right, and where did I get 0 from? Right here for my x value, and then I'll plug in for my y. So 0 is, well, basically it's 0, and times negative is 0, times 2 is 0, 0, and then we get 3. All right, and I can double check that and plug in a 2 here to see if that will also end up as 3. So we're like 2 squared is 4, negative, and negative 4, and then 2 times 2 is 4. Oh, look at these two. They cancel each other out, plus 3. Well, since these two cancel each other out, I'm left with 3, and so there I go. Now, to finish this out, I can either plug in negative 1 or I can plug in 3. It's really up to me. They should come out the same. So you get to choose which one you are more comfortable with. I'll plug in the negative 1. Why don't you plug in the 3, see what you get. Pause the video. Let's roll. All right. Okay, so thanks for unpausing it, and here we go. So I'm going to plug in the negative 1. Negative 1 squared is positive 1, but then I have a negative waiting for it on the outside, so it's negative 1 again. And then I have minus 2 plus 3, okay? And so then I end up with negative 1 minus 2 is negative 3 plus 3 is 0, okay? Now, if you remember, I said that the y-intercept is your c. The y-intercept is my c, so it should be intercepting the y-axis at 3. So here I go at 0... 0, 3, what am I doing? At 0, 3, 1, 2, 3. All right, and we have, what was it, 2, 3, so 1, 2, 1, 2, 3. Oh, I see what I meant. Okay, and then I have negative 1, 0, and then I have 3, 0. All right, 1, 2, 3, 0. And then I do this action. All right, kind of missed my points, my bad. All right, so, hey, look. The graph is extending downwards for any face because it's got a negative a, all right? And one of the other things that we keep in mind is that this time, instead of having a minimum, this has a maximum. It has a highest point. Why does it have a highest point? Because it extends infinitely negative, kind of like the United States federal debt. Anyway, so it infinitely can go negative. And so, yeah. With that in mind, this is the way that we graph quadratics, and so I've gone ahead and I've graphed all these quadratics. I hope this made sense. I hope that you enjoy this video. Give it a thumbs up if you like it, and if you don't, sure, send me constructive criticism, because I always want to improve, because you're worth it. So take care. I hope you guys are doing well, and I hope you guys enjoy unicorns, and it's great been talking to you. Peace! I'm out.